Hello students. Welcome to the YouTube channel, Physics Simplified. In this video, we will learn one of the important concepts of kinematics. So, without any further delay, let's jump into the discussion. Today's topic of discussion, the average velocity. A particle's position, say x, is the location of the particle with respect to a chosen reference point, which can be considered to be the origin of a coordinate system. The motion of a particle is completely known to us if the position of the particle in space is known at all times. Let us consider a bird flying back and forth along the x-axis, as shown in the figure. When we begin collecting position data, the bird is 30 meters to the right of the reference position given by x equal to 0. We will use the particle model by identifying some point on the bird as a particle representing the entire bird. Once every 10 seconds, the bird's position is noted and is tabulated. As per the table, the bird flies to the right during the first 10 seconds of motion from position A to position B. Let us consider this direction as the positive direction of motion. After B, the position values begin to decrease because the bird is now flying towards left from the position B through position F when we stop recording information after our sixth data point. A graphical representation of this information is presented. This type of a plot is called a position time graph. Given the data in the table, the change in position of the bird for various time intervals can be easily determined. This change in position for a given time interval is the displacement of a particle in that time interval. It must be noted that the data in the table result only in the 6 data points in the graph. So, the motion of the bird is not completely known because we don't know its position at all times. The smooth curve drawn through the 6 points in the graph can be considered only a possibility of the actual motion of the bird. As we have no idea what happened between the data points, the smooth curve is a guess as to what happened. If the smooth curve does represent the actual motion of the bird, the graph contains complete information about the entire 50-second interval during which we watch the bird fly. It is much easier to see changes in position from the graph than from a table of numbers. From the graph it is clear that the bird covers more distance during the middle of the 50-second interval than at the end. Between positions C and D, the bird flies approximately 40 meters, but during the last 10 seconds, between positions E and F, it flies less than half of that. A common way of comparing these different motions is to divide the displacement that occurs between two clock readings by the value of that particular time interval. This ratio is known as the average velocity. So, the average velocity of a particle is defined as the net displacement of the particle, in this case, delta x, divided by the time interval, delta t, during which the displacement occurs. In mathematical notation, the average velocity is given by vector v suffix x av is equal to vector delta x divided by delta t. In words, average velocity is equal to net displacement divided by the corresponding time interval. So, to find the average velocity, we need to know the total or net displacement from the initial to the final position and need not consider the nature of motion between the initial and final positions. It must be remembered that the average velocity of a particle moving in one dimension can be positive or negative, depending on the sign of the displacement. We know that the displacement of a particle moving in one dimension, say, along x-axis, is given by vector delta x is equal to vector x suffix f minus vector x suffix I. If the coordinate of the particle increases in time, that is, if x suffix f is greater than x suffix I, delta x is positive, and so also the average velocity. This corresponds to a particle moving in the positive x direction, that is, toward larger values of x. If the coordinate decreases in time, that is, if x suffix f is less than x suffix I, delta x is negative, and so also the average velocity. This corresponds to a particle moving in the negative x direction. The average velocity can be interpreted geometrically by drawing a straight line between any 2 points on the position time graph. We choose the 2 points to be A and B. This line forms the hypotenuse of a right-angled triangle ABP. It must be noted that the straight line between positions A and B is the chord of the graph for the selected interval of time. Now for the right-angled triangle ABP, BP is the height, representing the displacement of the particle, given by delta x, and AP is the base, representing the corresponding time interval, given by delta t. According to the figure, the chord makes an angle theta with the time axis. To find the slope of the chord, we need to determine the value of tan theta. So, slope of the chord is equal to tan theta, which is equal to the ratio of delta x and delta t. This is what we have defined as the average velocity. So, we can state that the slope of a chord in displacement time graph for a given interval of time is equal to the average velocity of the particle for that time interval. Before concluding today's topic, let us try to learn what is the physical meaning of average velocity. Remember, average velocity is that uniform velocity with which if a particle moves, it undergoes the same displacement in a given time interval as it does with its actual velocity in the same time interval.